Welcome back to AI Searched. We're so excited to be here in Geneva today at CERN, talking to Ema Puljak. Hey Emma, how are you doing today?
Hi, I'm good.
Perfect.
You?
Great, thank you. Tell me a little bit about what you're doing at CERN, like about your doctorate and your research.
Okay, so actually my university is in Barcelona, but I was doing a doctorate research at CERN, and it's, how would I call my PhD thesis, is about advancing anomaly detection algorithms and applied in medical imaging and high energy physics to look for new particles with quantum and quantum-inspired methods. That's it in like a small summary of our research. Yeah.
And where can we see quantum computing in real life use cases?
Today,
yeah.
Yes, so what we were doing is that at CERN, since we use the data at CERN is in nature quantum, so we were thinking, okay, if we can use the entanglement superpositions of the qubits to kind of enhance the search for new particles, and we found that in some regimes, yes, it's possible to make quantum algorithms perform better than the classical ones, but these are in specific regimes, so I cannot claim it's a quantum advantage.
Yeah.
So in this setup, but yes, so there is some kind of good research going on in that direction. But then for drug discovery, for example, you can simulate molecules in quantum chemistry with AI. You can simulate molecules in that way, because today on classical hardware you cannot simulate some molecules because it's very computationally expensive. But then if you use quantum hardware, you can profit on that side and then discover new drugs. Then there are some quantum optimization algorithms that can be used for, I don't know, optimizing routes in traffic or portfolio optimizations. And also quantum kernel methods are very good. We were using them for the research in the physics as well.
Yeah.
So they can kind of analyze this, like some complex patterns data better than the classical kernels.
Nice. And what does the hardware look like that you're working on, and how is this hardware getting optimized?
Okay, so well, there are two types of hardware. Like there are these quantum annealers. They are specified for a specific optimization problem, so they can have more qubits, but they are connected in a special way for that optimization problem. But then you have these general purpose quantum processors. Today the highest number of qubits is 1,000 something. It's from IBM, but the whole area of general purpose quantum computing is that they are searching qubit, like setup of these processors where you can do any arbitrary operation on qubits. Okay. And today this is very hard because since qubits are very sensitive systems, they collapse to be in a classical information after some amount of time, very small amount of time.
Yeah.
And then you need to correct these qubits, but to correct them you need to correct one qubit, you need more
energy.
more physical qubits to correct one. And this whole area called area of quantum error correcting codes, and this is very slowly developing because of some challenges in quantum hardware. So it's gonna happen, but
it's getting better and better as time
every
goes
day.
by.
Yes,
Incredible. In your career, like, what are you looking forward to? You know, using your research now. You know, you've done your doctorate, and what are you looking forward to, including that into career or into your future life working in this field?
Okay, so what I really like is to benchmark these quantum algorithms. So basically, to compare them to classical counterparts, or to dequantize quantum algorithms to like a classical simulation. And this is I think it's very important to benchmark them for you to be able to see, okay, this is really useful. Like this quantum algorithm is like really useful for us for some use case, like you would do for any state-of-the-art machine learning algorithm. So I think it's very important to benchmark them, not to just say, okay, this is quantum and then it's better.
Yeah.
So this is what I like to do. Yeah.
Yeah. And just the last question, like, what would you advise someone who's like inspired about this field and kind of just starting out? You know, what brought you so much excitement in this field, and what do what would you advise for the younger generation?
Yeah. Okay. So, well, if you're coming from computer science as I do, it's hard at the beginning to understand some concepts. But I think today there is a lot of material for this. There is a lot of tutorials, a lot of seminars that people do for actually computer scientists. So I think it's very possible, like if you're interested in like some new generation, like future applications of computers, then I think it's very exciting to be a part of this field, and I think now is maybe the time to go into this field, because later it will be much harder, because it's going to be like machine learning or like AI. Everyone is now in AI. I think now is a good time to like start going into this field. Yeah.
Super. Yeah. Thank you so much for talking to us. Yeah.
Thank you for inviting me.
You can watch AI Searched on YouTube, Spotify, and Apple Podcasts.